We're going to do this trigonometry problem, prove the identity, and this is always a pain in the neck for most trig students. You have to remember a lot of algebra to be able to do this. So I tell my students, you see identity, so something really straightforward here on the left and something really complicated on the right. So you always want to start with the more complicated side and then just simplify using identities from trig to make it look like the other side. So I'm going to do my proof. I always label it 1 minus sine squared, or sine t over cosine squared t plus 1 over 1 minus sine t is where we're going to start. So the first thing we're going to do is find a common denominator and add the two together. The reason why I'm doing that is because I have two things here and I want it to be one thing here. So that's probably the best place to start. So my common denominator is just the product of the two denominators there. So cosine squared t times the quantity 1 minus sine t. Now, when I look at this, I think to myself, okay, what's missing in the denominator here that I need to match that denominator? And that would be 1 minus sine t. So I have to multiply top and bottom here by 1 minus sine t. So it'll be 1 minus sine t times 1 minus sine t. And then here what's missing is cosine squared t. So I have to multiply top and bottom by cosine squared t. So 1 times cosine squared t is cosine squared t, and it'll all be over the one common denominator of cosine squared t 1 minus sine t. Now a lot of students say, well, how is that legal? How are you doing that? Well, just think about the numbers. If I was adding 2/3 plus 5/3, I could say that's 2 plus 5 over 3. That's exactly what I've done here. I've made sure the denominators were the same, and then I just added the numerators and kept the denominator. That's common fractions. Don't forget stuff like that. All right, now what I'm going to do is multiply out the numerator and simplify. Let me scroll this up a little bit. So in order to multiply this out, I have to do distributive property, or commonly known as FOILing. So 1 times 1, 1 times minus sine t, minus sine t times 1, and then minus sine t times minus sine t is plus sine squared t. And then plus cosine squared t. So these first 4 is that multiplied out, and then cosine squared t. And the bottom stays the same. Don't multiply out the denominator. Just leave it. Don't distribute. I know we get distribute happy and FOIL happy and all that kind of stuff, but you don't have to do it all the time. Now I'm going to continue simplifying on the top. But this is a beautiful little theorem right here, sine squared plus cosine squared, and that's going to equal 1. And then I can add these two together. So the numerator then becomes 1 minus 2 sine t. 1 sine t plus 1 sine t is 2 sine t, plus 1, divided by cosine squared t, 1 minus sine squared, or sine t. I keep saying sine squared, sorry about that. Continuing, I can add the ones on the top. Keep the denominator. I can factor out, now I'm going to factor out a 2 in the numerator, and the reason being is I know what's going to be left is going to look just like that. So I'm going to write this as 2 times 1 minus sine t. Now, if you ever wonder about a step that I've done, you can go backwards. So in other words, you can go back from here to here and say, well, if I distribute that 2, does it look like that? Now I have this factor of 1 I can reduce, and I'm left with then, hold on, sorry. I'm left with 2 over cosine squared t, which can be written as 2 times 1 over cosine squared t, which is then equal to 2 times secant squared t. And if you take a look at the original, that's what we want. So down here, I can say that I am done. You know, you can put QED or your little rectangle or whatever you want to say that you're finished. But I've just proved the identity.